He is an engineer that loves big data. It is his passion. He's an engineer at Interana. And he's going to talk about tips and tricks for processing trillions of records of data, specifically clicks. Trillions of clicks in seconds. So, everyone, Jag.
So I appreciate you guys coming in on Saturday at 3 o'clock in a classroom. That takes a lot of dedication. Okay, so here's what I'm going to talk about today, and I'm kind of going to gauge the room about like what was on here. We're going to talk about behavior, right? And behavioral queries is kind of a new thing that's strongly aligned with how users engage with products now. So when I started like 15 years ago, my first project was a satellite project. We had like 2 users. So I was like, okay, design this to work for 2 users, right? And, you know, you can watch these 2 users, you can figure out what they're doing, and you know how to build the product. Things have changed. We have a little bit more than 2 users for most of the products that you guys are working on, if you're going to get paid. And so there's things about behavior that is only realized once we know how to store the data and access the data and understand what behavior users impart and how they impacts their usability of their application. And you want to use this data to build your application out, right? You know, before data was there, you'd have like 3 experts. They'd all debate around the circle. Well, what do you think the product should be? After some Chinese food and a long night, somebody would win. That guy got to implement his feature. Things have changed now. Turnaround cycles for products that we're helping out with is less than an hour. When you make a deployment into the internet, like I think it was Amazon 3-4 years ago, that talks about every second that something's slow or unoptimal, there was millions of dollars of business every day. So it's really important to understand the behavior of users on your site. You want that data pretty fast because the faster you can make a decision, the faster you can react to different problems on your site. I know that big data has been synonymous with Hadoop. And Hadoop is great. I've used it before, and I really recommend that if you guys haven't done any big data, Hadoop is always a great way to start to understand how big data works. But there comes a time where you don't just want to store the data, but you want to access it and ask it really complex questions. You want to do it in real time. You want to do it as you're deploying to your public website or your application. And you might have a lot of data to go over. So there may be, the one thing that may happen is there may be a holiday today, and you deploy something the day before, and you see different behavior on your site. You want to quickly find out what is the average behavior on your site, and is that behavior today related to being a holiday or your source or your deployment of your software? If you can't distinguish the difference, then A, you're going to maybe punish good behavior, like people actually doing good things with your software because it's changed and you understand why it's changed. I've seen that over and over again, where people will get top line numbers and say, oh, the users have dropped, or they're taking longer to go through this part of the funnel, and sometimes that's a good thing, right? So to understand why people do things, it allows you to optimize your software. And I'm going to talk about just in deployment, depending on how technical you guys are, maybe I'll skip through that. So maybe we're going to show of hands. How many people here work with data and are on engineering teams of any kind, like product or anything? Okay, about half. Cool, so I'll make it pretty even. I'll go through some engineering concepts. I'll make it super technical then. And deployment, like if you want to use Interana, how would that work? How would the deployment model work, and how we allow people to go through and store hundreds of terabytes of data and trillions of rows. Okay. So who am I? I'm a big data engineer in Interana. I have a lot of experience in event data and big data. I started data almost 15 years ago in space sciences and satellites. So my first job was to work on telemetry and telecommanding to satellites and to study the behavior of satellites. So our satellites were constrained. You would image on a satellite, each thing was an event, and you want to look at thermal models and things like that. And it ended up being event data. I didn't realize at the time that it was event data, but now going through this kind of journey of work with Interana and other public startups, I realized that was my very beginnings of event data almost 15 years ago. And the thing that changed a lot is we had something like a 2 gigabyte hard drive, and I was told well, if it goes over a gigabyte, we're going to be in real trouble. And we had about 1 million rows of data, and that was scary. Even at that 1 million rows back then, we had to cache a lot of the data. Right? We couldn't actually access the data as it was stored, which is a big problem, because once you cache data, you always lose information about the original data that was there. see. So what's data over opinion? I'm wearing this shirt here. So data culture. What is data culture? So data culture is being able to make decisions based on data rather than opinions, right? And it's really hard. So if you're in a meeting and there's a crucial moment where people are going to decide what to do, to be able to have a data-driven culture, you need to be able to access that data really fast. So a lot of our customers actually have Interana go to meetings in real time trying to get answers about what the way website behavior is, what the user behavior is. To do that, you need something that you can actually ask questions in real time. You need something also that's flexible, right? So again, using the Hadoop analogy, Hadoop's great when you understand what kind of data you want to mine, right? Here, you might not know what kind of data you want to mine. Like for example, a session. A user session is very variable. A user session may be a login, a bunch of stuff, and log out. A user session may be on a site like one of our customers, Imager, nobody ever logs in. What's a session there? You have to define it. So in those cases, you can define a session as something that is a stream of events followed by 30 minutes where they don't touch the computer. And that's a virtual session. So typically, when I've worked with sessions before, you have to code it into the website. You say, oh, when somebody comes on, you give them a session ID, then you give another session ID. But that makes it very static. It's embedded in the data. What Interana allows you to do, it allows you to make those decisions at design time, input all your data, and decide what a session is on the fly. And sessions and also funnels are the same thing. So you might, a lot of people focus on the purchase funnel. A purchase funnel for a site, maybe I click on an ad, I go to a site, I browse around, find a product I want to buy, add it to my cart, and then I put my credit card in and order it. So that's the typical funnel. But different team may have a different view. Another team might be the customer satisfaction team. And their version of the funnel may not start with the advertising because they don't care about that. They care about satisfaction, and they want a satisfaction survey after you bought the product. To do that, their funnel would be maybe more like starting when the person adds the product to the cart, buys it, and then what do they do when they build the survey? Right? So it's very dynamic. And as you have a startup discussion, you build these teams up, you don't have time to re-code all your software. You need to have all this information going into a database so you can query it. So this is what the data over opinion means. Our founders are from Facebook, and they worked on Facebook in the early days when Facebook went from million users to billion users, and so they know about the problems that happen at scale. So the system is really designed for scale. While you can work on it with a billion rows seems like a lot, but that to us is like really small. We get really excited when we get up to trillions and trillions of rows and terabytes of data. And what Interana is a cluster that allows you to be a full-time data scientist, product analyst, and once you set this stack up, you can do whatever you want without having to go back to the engineering team. And that's really key. So once you do the initial upfront engineering to get the data in there, there's no more interactions with the engineering team. You can then interact with the tool itself and do all the queries that you might want to do without having to write Hadoop jobs. And anybody who's written a Hadoop job here knows the pain in being able to calibrate, make those things run properly, and over time make sure that they're actually correct. So let's go to the next slide. Here's some of our customers. So this is a quick history of the company. I don't want to go into much detail, but we were stealth for 2 years. We came out last year and started offering our product up. So this is the company we signed the first year. Probably a lot of recognizable names. The key thing here to know is we're not just integrating with these companies, we're literally owning all their data, right? So each one of these companies here have a minimum of a few terabytes up to hundreds of terabytes of data. And it's not like data related to the HR or finance, it's like what are your users doing on your site? It's the most valuable data for these companies. And so it shows that we've got a lot of traction in being able to solve the hardest problems in the world already. Because of that, we have a lot less customers because each one of these was like trying to figure out how to use this tool for each one of the use cases. Now I think with this depth of companies that we do have, you can go on our site and look at use case studies. We probably serve up, we probably have use case studies for almost every other sub case that you guys might face, whether it's finance, whether it's website monitoring, whether it's user behavior, whether it's ad funneling. Cool. Okay, so these are the use cases. So I just talked about dynamic sessions, being able to define a session on the fly. The session is basically a stream of activity by a user. In our system, we can define it as a pair of events or we can define it as a period of inactivity or activity, whichever way you want to think of it. And that'll create a new session. Once you create a session, you can say, what's the average time the user interacts on a site before they get bored and they walk away? Very important every time. Then, some more interesting things you can ask. What happens when an error shows up on a site, and how does that change the engagement of the user? How does that change their buying behavior? Does it fall off by a few percent? Does it fall off by 50% less when they see an error? Right? You're going to see errors in websites. Also, you can also drill down and you can say, when there's an error, what types of users are more likely to fall off and not purchase stuff? And in a couple of use cases that we had even last week, there was a company that was seeing that there was a certain type of error that was affecting certain age ranges. So there was like an older age range that was in a certain area in the US that there was a certain type of error that happened, and that cohort of users, conversion rate fell off. So what does that mean? It means that your site's not down, it's just not performing properly for one cohort of users. That's the level of fidelity you want to give people who are using our database. I won't go into too much details about the other ones. Purchase ad funnels that we talked about. Continuous deployment, A/B testing, that's pretty commonplace if you're a data scientist. Continuous deployment is really exciting. That's the ability to deploy, just like I just mentioned, deploy, figure out what's wrong, and then roll back within an hour, right? So, your friend might get onto a site and say, oh, the site didn't load, it didn't load for me. And the other guy, your other friend might go up to the same site, yeah, it's loading just fine. That's because we're able to real-time control that behavior, figure out what percent of users sees any feature, and then roll it back before it gets out there to everybody. So it doesn't see impact. Really important to be agile people today. Bot detection and unauthorized usage, so misusage of the app. I think we had a case where on Tinder, there's a bunch of people who were always swiping left, and they found that they created a cohort of these users and blocked them. So that's really important, right? When people are trying to game your application and use it in a way that's not good for the rest of the users, we can detect that and we can stop that activity. So what's behavior? This is an example of how we think about data. We have users with streams of things that users done. So imagine the green circles is like an ad. So these users came onto our site and they clicked on an ad. These other shapes and colors in between are things they're doing on the website. And finally at the end, those two square boxes at the end represent a purchase that they made. So what do you want to do? You want to analyze what are the things they did make the purchase. What is good purchase behavior? You might say user D and user B have some sort of cadence. Like people who click at a certain cadence might convert more. So that's a way to indicate when before they convert that when the cadence means like time between clicks starts to increase, you might want to push something to your site to those users and say, hey, did you see this deal? Right, real time. And so those things you can analyze once you have data in this format, which is not the general format of any database I've seen. So we treat this as first class. And for some of our customers, they have 1 million users, and each user has thousands of clicks. Imagine how big this gets. And they want to get the information and behavior about that user real time so they can make these decisions and actually push changes to the content on the site or their mobile app in real time. And that makes a difference once you start scaling.
Can I ask a question for you on this one?
Yeah,
Can you go to the previous slide?
Yeah.
Does the task, so each shape represents a task, does the purchase, which is the end game, do you think it's the order of the tasks that makes the difference, or just the task itself in any order?
That's a great question. So that's the kind of thing you can dive into. That's what they call funnel behavior. So you decide like what things in the funnel make people drop off. Looking at this, I'm predicting right now, whatever that green cross is, maybe that causes people not to buy things.
Right.
And so you can query our analytics engine and it'll tell you that. And then you might want to take that green cross out and maybe those two people become buyers and now suddenly your conversion rate doubled. So absolutely.
Thank you.
I won't go into this too much, this is verbiage. So we have users, a user is an actor. The reason we call them actors is because a user could be also, like you think of a device, you're interested in how your devices are doing. So it could be any entity that's important to you as a business. It could be for like a streaming music service, it could be the songs that they're playing, that could be the entity. And you can have multiple entities, there's always not one like golden metric. Usually people have users and something else like a device. And those are two things that they call actors, and those are two most important things to kind of slice off when you're looking at data. So generally we say at time T, Jack gets a purchase, Jack clicks on a click. That's a row in our database. It's an event. So an event is something that happens, right? And that's all we really store. But with that event, we might have hundreds of columns describing Jack, describing people like Jack, and describing his, like, what's in his cookie information, all that kind of stuff. That's a big column. So we use columns for that. I'm going to speed up a bit because I think I'm going to be short. Yeah. So this is something I think you should go to our site and read up on it. Will make more sense. But then when we talk about funnel, I'm talking about budget trends, so I'll focus on that a bit because that's kind of the exciting one. That's kind of our main bread and butter for this product, is that we can view funnels and make them apply. So the average company makes 20 to 30 different funnels. Each of those funnels view how the behavior of the website changes. And there are things like metrics, which is like you can, I don't know, you can take like so what they paid for a certain product, and then you can figure out how much tax was on that product and make a metric without actually having to put it in the database. You can create all these rules to create product metrics, right? The nice thing I like about our metric system is we don't store the data, we store the equations, so you don't have to pay for the storage, which is actually key when you have 100 terabytes and you add like 7 equations, I have 700 terabytes, you're a lot of money. So this is what it looks like. This is how we store the data. It's actually physically how we store on disk, for people who want to nerd out a little bit here. So we have, if you ever use Cassandra, we're very similar to Cassandra, but a few major differences. We always use timestamp as the sorting order, the partition key, and that is because any kind of solution I've ever seen that's big data always has a time axis that's moving. And if you don't have a time associated with any data, it might probably not be that big. Like you can say I have a database of users and that's a billion users. That's not really even that big for us. Right? To get to trillion, you got to have users that do something. It's always going to be a time axis. It also works well in the computer level for caching. You can always range on time and it uses efficiently because the data resources. And so we have these things called shard keys and sharding. I'm not going to go into sharding basics, but that's how we shard data. And for each one of those rows, we have behaviors. So that's the thing the person does. They have hundreds of behaviors, thousands of behaviors. Like there could be pages they're on, things they clicked on. It could be even like, we have things going on with IoT where people shake their phone and we can actually measure them shaking their phone. That also is behavior. And finally, is alcoholic drink that they clicked on. So you want to see are people who are clicking on alcoholic drinks converting more than people who are not alcoholic drinks, not because they're alcoholics. And so we can do that. So you store all that data there and now you can ask all those questions. As you store more data, you get more questions, but you don't get penalized for storing more data. That's the key thing. And then the yellow represents a session. So when I talk about session, this is Jill's one stream of things she did. She clicked on an ad, this is spelled incorrectly, but maybe she's not knows. She clicked on an ad, and she added a product to her cart, which she loved, she didn't buy. Jack clicked on an ad, added a cart, and she purchased it. That's one session, right? And then Jack and Jill may come back and they may be working some other sessions. And you can see what they're doing for each one of these sessions and ask questions. Performance, okay, so I'm not going to go into too much details here, but I think we wrote everything in C++. There's MemMap, which is a memory paradigm for Linux, makes things go faster, loading from data to RAM. Pipelining and compression are really important things that are really hard. So the people who wrote this were like kernel developers for Linux. So they have this paper on how they did this, and I'm not going to go into detail, I barely understand it. But basically, they utilize the hardware better than you would if you don't pay attention to that stuff. And that's, I think, one difference between some of these open source alternatives I've seen. Especially if you use Java, you can't access the actual computer hardware and the registers on the computer as well as you like because they're virtualized. Because we're in the C++, you can access and you make use of the cache. The cache will actually, people don't realize, like, oh, put everything in RAM, that'll go fast. Put in cache, it'll go 10x faster than RAM. And if you don't utilize that, you're just wasting your CPU cycle to do nothing. And trillions of rows in there will go off. This is a really important graph. If you're a computer science major, you should know this. This will be on an interview question one day. So the cost of operations. So starting at disks are really slow. Even the fastest disks are relatively slow. They're 41 million times slower than RAM on average, right? So it's really slow to go from disk. Once you get data into your RAM of your computer, things speed up. Like you can see, well, 41 billion to 250x. So what it is. But then, this may not seem so sexy going from RAM to cache. But like, let's say you have a query and it was like a Hadoop query and it was taking like a minute. Well, if it's in RAM, it's a minute. That's not bad. But if it's in cache, you're a lot better off. You're going to be down to 10 seconds. So when we say we like to have all our queries come back in 10 seconds, that's why we're able to use the caching. I'm going to speak to some of this. Is very, very technical here. We use sampling. I'm going to quickly explain what sampling is. So when you have an election and you log in or you get off work, you come home, you turn on the TV, at 6 o'clock they tell you like whether it's Democrats or Republicans have won. And only 40% of the people have actually voted. So the important thing is you know the answer, but you don't have to wait for the very last ballot to be cast. That's the fundamental difference between like MySQL and a lot of databases I've seen and sampling databases. So sampling is a relatively new thing. I know Blink does it. I'm not sure how many other DBs do sampling. One is you can get the answer in direction of what you're looking for without looking at all the data. So when I actually lied on my previous slide, I said trillions of rows. You don't look at trillions, you look at a sample set of trillions. It ends up being still billions, right? But billions you can get back in 10 seconds. If somebody says, oh, we read trillion rows in 10 seconds, like actually read those, like, you can't. You need like petahertz computers to do that. We don't have petahertz computers, but computers. This is nothing exciting to developer. I'm going to speak to some of this. This is how we ingest data. We use Amazon, Azure, or file server. So we suck data from files. But just like if you've ever done CSV into Excel, you can do the same thing. Obviously, doing it at hundreds of terabytes of scale is a little different. And you're also now supporting like HTTP REST. So if you have a REST endpoint and you want to post right into REST endpoint on the site, you can do that. Okay. I'm going to speak to this Columnar Format. Sorry, this is like a technical topic. I now regret picking this slide. Bottom line is we store the data on disk as if you're going to access it. Thus, that is the key to big data, or NoSQL. So the NoSQL, if you've gone to any of these other presentations, we'll talk about storage matters. And so we optimize our storage for the type of thing we're doing. So if you take any other column of store and try to do the same level of queries, you won't be able to at that speed. You can do them, but it'll be way slow because storage matters. So you have to kind of pick in the NoSQL world, what am I optimizing for? And if you're not optimizing for anything, then you're better off using SQL and going on that path. Okay, I'm going to finish off. This is what a cluster looks like. It's got 5 different types of nodes. If you looked at Mongo or Cassandra, this kind of looks similar. You got the biggest thing is we keep data in string nodes different because data are floating point numbers and string nodes are strings. And the reason is data that is floating point compresses really well, and that also gives us a bigger speed up. So this is like a little bit of a trick. I actually stumbled upon this in my previous company, built it, and I was showing off at some at some conference, and some guy came to me, he's like, oh yeah, we already do this. I'm like, really? And I'm like, oh, and then I started to show off to him, and he's like, no, we do it better than you. I'm like, oh crap, you do. So that's the trick. When you have heterogeneous data, you want to keep it separately. All right, so there's some performance number here. This is a real cluster, 70 terabytes of storage, 1,000 columns. The biggest database I've worked on before I came here was 1 billion rows. The biggest MySQL database was like 1 million rows. It's exponential increase in data. 70 terabytes of storage. If you can afford to do a demo of this, you probably have a lot of money, or you know how to stop Amazon clusters really quickly. Either way, you can see I ran this history on one of our clients. 2 trillion rows, we were able to get these kind of queries back in 2 to 5 seconds. Funnels take a little longer, 10 seconds. So sampling, like I talked about sampling, is really fast. Unsampled means get all the data, like every row, and you can see it slows down. It's still like not bad, 60 seconds, you can wait for that. You can ask, you can do 10 of these queries, figure out the one you really want, and do what it wants, and you're like, you saved yourself a lot of time by sampling and not doing some queries. All right, how much time do you have about? 5 minutes. Oh, perfect. Okay, so I'm doing my demo. I might not do too much because I'm running out of time, but this is the data set. It's a music data set, think of like Spotify. So you have users who click on songs and images. Click on songs and listen to different artists. I'll just quickly show you, because I can, what it looks like. So this is a real product. I'm going to go to dashboard here, and this is what we do. So all of these queries are, well, some of them are going through billions and billions of rows. So this is a 4.77 billion row data set, which is actually pretty small for us. And this is a kind of different type of queries you can do. You do this group by pie chart. Look at paid users versus free users. How many people, how's your paid users, which is in green, changing as you have free users? Because you have a freemium data model, are they converting? There's nerdy statistical stuff. This is a histogram distribution. So this is saying, out of 7 days in the last week, what percentage of users use the product every day? So you can see here, 20% of your users use the product every day. So once people wake up every morning, they listen to their Spotify track records, they're going to work. And you see these people here, only once a day, they use Spotify. Maybe these people on the weekend only use Spotify or your music service, and they maybe go to parties on the weekend, and that's when they use it. I don't know, right? So there's further things you might want to click in and find out about. Finally, last thing I'll show you, since we're really short on time, is a user session. So this is an example. I'm going to define a user session as a user who does a stream of events and is inactive for 30 minutes. Then create a new session. So each one of these sessions, we can ask different questions. How many artists did they listen before they went and stopped using the service? How many songs did they listen to? And how many errors did they encounter? So clicking on this, I can go to the file window here, explore. And you can see, I don't know what's the best one is. Maybe it's distribution. Oh, I can't do this. Let's focus on that. It's not really a good engineer to do this thing. I think I'll stick to time graph for now. All right, so this is the average duration of a user session over the last, just look at the screen here, 2 months. Up here, if you can read that, that's 232 million rows. And this is a unsampled query actually. So let's do a sample query and see if we came back after a millisecond. And the nice thing we have here, we really thought about the user. So let's see when we look at the last 2 years, 2 years ago. So there's this natural language input we use. And you go to enter. And in 2 years, 4.77 billion events came back in 3 seconds. Okay, so to go through the whole depth of what this can do would take me like an hour. I just want to show you how fast it is, how much information you can glean from it, and that it is actually real and a lot of people use it. I think that's about it for today. So thank you very much. So does anybody have any questions? I know it's really fast. Any questions about our engineering or product or any use cases, anything? Yeah.
I saw that Microsoft is one of your customers. May I know what type of product it is using?
Yeah, absolutely. Yeah. So Microsoft's our biggest customer. They actually have, little knows about Microsoft. Microsoft's not one company, it's like 20 companies. They don't talk to each other. So luckily for us, we get to sell this over and over again for Microsoft. We sold 3 divisions already. The one that's public is Bing. So Bing is obviously a competitor to Google search engine. It's 10% of the world's queries, which is a measly like 10 billion a day or something. She's doing more than that. Actually, I won't quote me there. I don't know what it is, but it's a big number. So they use our tool to figure out if there's bots, if there's malicious activity on Bing, and for continuous integration. So Bing actually rolls an update to the site every 1 hour. And they measure those upgrades and they roll it back. So I was talking about all of that stuff in the beginning about people doing that. Bing is actually one of our biggest customers that do that. Their data size, I can't publicly say exactly, but it's one of the biggest. They retain less than 3 months of data, and it ends up with like hundreds of terabytes. So we have to continuously trim it. Even Microsoft couldn't afford to keep more data. It wasn't like we couldn't handle it. They didn't want to pay the money. And the funny story is, Microsoft has Azure cloud, so it's deployed in their cloud, but they couldn't afford to pay their own Azure to expose more data. So we're kind of looking for people that have more data. We're kind of bored. But if we do this now, does anybody have enough money to buy more storage? Contact us and we'll spend it for you happily.
So they probably retain that data, they just don't keep it in Interana.
They retain the data, but they're not able to query it anymore.
Yeah, in Interana, they
Yeah.
keep it somewhere else.
They keep it somewhere else, and they, ingest into a system.
They could put it in Interana at a later point if they wanted to.
Yeah, once they have enough money,
Yeah.
clearly a too small company.
All right, they need their Microsoft bucks.
Yeah, exactly. Cool. All right. All right, that's good. Thank you very much for attending. Like I said, I built this one. Yeah, I'm not going to do that. Yeah, we're